Hey, don't secret agents have to deal with security too, or is it security have to deal with agents? We're trying to figure that out. What's the security with all the agents that we're creating here on the Textron gang? Well, welcome back. You're joining our elite team here of Textron gangers. I guess we are gang members. Mitch Ashley here with Futurum. Great to be joined by our crew of Jack Fowler and Stephen Foskett. Guys, welcome.
Welcome. Thank you.
Great to be here. I am definitely a secret agent.
You are. Well, that's what I was thinking about. Agents, aren't they like secret? And don't they deal with security? And suddenly now, we talk about secrets of agents. I know that's what we're going to get into. Matter of fact, there's some really good articles that are up on Security Boulevard and also on DevOps.com talking about security around MCP servers. It seems like the topic has been come up but not been addressed. We talk about security for agents. We talk about identity here and there. Are they team members? Are they whatever? How do they get their permissions? But there doesn't seem to be any real solid frameworks around agents today, at least not yet. Now you can look into some of the open standards and say there may be some things there, but I don't think, Jack, somebody in the security community is going to say, yeah, I'm happy with everything. Looks good to me.
No, I think it's the exact opposite. In fact, the entire security, identity security world sort of shakes their head and looks at it and does the face palm and, what are you thinking when you created MCP and had no concept of identity in MCP and said, oh, we'll just wave our hands and do some OAuth tokens or something else and let somebody else deal with it. The challenge is really that we're moving from a human world to an agent world where agents act on behalf of humans. And it's important to understand the agent's identity, the server's identity, the human who's the agent is acting on behalf of or for the benefits of identity in every single transaction that occurs. And right now there's a lot of anonymity, and anonymity in security is a bad thing, right? So there's a lot of talk about at the high level, here's some high level constructs we need to think about. And so I wrote an article about some identity security folks coming out and saying, there's a lot of issues with anonymity, with how you communicate the information back and forth, how often you go back to the user to re-authenticate to get permissions, and how to make that cleaner. And here's some high level thoughts to think about it. But we haven't moved beyond that to here's an actual protocol that actually thinks about it and cares about it. And the big concern is we're running at 1,000,000 miles an hour trying to make agents useful and get money out of them without thinking about the security. And that's just generally a bad thing in my book.
And we can't wait for them to be agentic, right, Stephen? At the same time, you host AI infrastructure field days and AI oriented things. I'm wondering how much is security coming up, and what are vendors saying about this?
Yeah, well, to be clear, Alistair hosts AI infrastructure field day.
Yes, that's true. Alistair
I host AI field day, and that's where this stuff comes up. AI field day. I know it's confusing because there's two that sound a lot like. And in fact, actually, the last week I was at NetApp Insight, and there was a lot of conversation there as well about this. First off, let me just say that article on Security Boulevard that about this topic is just really excellent because it goes over a lot of the potential issues with agents in a very clear, straightforward way. And it's so true. I mean, just think about what is being pitched at us about agentic AI. It'll automatically, find the right flight for you and book it. Wait a second, right? Do I really want my browser? Do I really want Perplexity to decide? How about, or even better, do I really want Google to decide which flight to buy and buy it without any approval? Or alternatively, as it says in there as well, there's that chaos of approvals. Or alternatively, do I really want to click the little button and say, buy me a flight, and then have it say, do I have your permission to access your calendar? Do I have your permission to access your email? Do I have your permission to access your frequent flyer accounts? Do I have your permission to, because again, that's another issue. Another other issue I want to point out, I was reading the Cloudflare blog last week, and they were talking about their one of their articles using MCP in code mode. Their thesis is we've all been using MCP wrong. Their suggestion is that instead of calling tools, what we should do is have MCP dynamically recode the calling and the APIs on our behalf automatically, and then run it as code instead of in MCP. And the whole time I'm reading that, I'm just thinking, but what about security? So essentially, we want to just tell AI every time the agents do anything, hey, go ahead and just rewrite this yourself. Like, just figure out how to do it, would you? And yeah, I mean, it's just a complete total nightmare. And so I want to point out what the clever thing that NetApp announced last week, and this is not going to solve this problem, but I liked one aspect of it. They are in their new AI data engine. They are using AI tools to do data classification and to then use that to enforce access controls on data. So instead of just saying like, I think you can access everything on that file share, you would be able to say you can access data related to Acme Corporation client, but no financial information. And then that way, and their idea was, and I completely agree with this, that the only way to keep an LLM from leaking data is to never let that data into the LLM to begin with. And they're using AI, but in no way that actually is exposing anything. They're just using it to create metadata. And then they're enforcing access based on the metadata that was created in a sort of a standard deterministic programmatic API type way. So it's not AI talking to AI. It's actually, you can't access this. You can only get this subset of data. And I love that idea.
Interesting. I was also at the Oracle last week at the now renamed AI World. And similar kind of approach of not only is it the data store, but that's, they have databases, massive databases, business applications, ERP, CRM, et cetera. And their approach was something similar where they said, look, the data never leaves this platform and AI will access it through MCP, but that MCP will be controlled by all of our existing security and privacy policies that you already implement in those products.
So that's like the same idea, except for structured data, whereas NetApp was talking specifically about unstructured and multimodal data.
Yep, makes a lot of sense. So it's interesting. I want to go back to the polymorphic topic you brought up of creating code, right? And we're already doing that. We just have it in the developer's hands when it's creating code for us, right? But that's very much where this is heading, is that agents will be able to create agents. Agents will be able to create code dynamically. And in doing so, yeah, it might be minor things, but still, that's how things get leaked in. That's how credentials get lost. All kinds of issues kind of come up. That article you were talking about on Security Boulevard, by the way, we'll put a link to it. Beyond Chatbots, why agent security is the industry's next major challenge. And there are like 10 items, I think there were, that came from the artificial intelligence identity management community group that had a number of these issues that they talked about that need to be addressed. So, I'm sure it's not everything, but I thought that was a good list too.
The interesting thing about all that and sort of the polymorphism is we do that a little bit today in a very subtle way, which is when you think about infrastructure as code, that really is another form of that, where we say, here is some code that defines the desired state of our environment. Now you go figure out how to write code to talk to agents or to have agents that go talk to different types of systems, whether it's servers or routers or storage devices, to get them configured the way you want them to operate. And in that environment, we still have a very big problem of anonymity of access, right? If you think about those types of environments and infrastructure as code, everything you're doing is a privileged access. You're operating as a super user or a system administrator where you can go change any configuration. You can delete hosts, delete servers, delete virtual machines to start multiple instances. And with the anonymity in there, it's very hard to audit and trace back who's doing what and why something actually happened. And hey, we just shut down our entire production server. What happened? Well, this agent turned it off, but why did that agent turn it off? I don't know, because somebody somewhere made a typo in an IAC file, but there's no way to tie all of that back together without a lot of manual effort. And very often, because it's all anonymous access, you can't. And that's part of the problem in the MCP world, as well as agents can take on and work for multiple people simultaneously, and they can do things autonomously, right? Where you say, hey, I want to buy an airline ticket, but that triggers many different actions, which could trigger many different agents to do things. As you said, access your calendar, put something on my calendar, or delete a meeting off of my calendar by mistake, right? Hey, that meeting disappeared. I don't know why it disappeared. Who made it disappear?
Where's that log? I feel like I'm reliving the dipping back here in history. The 12 blinking clock on the VHS tape deck. I can barely keep HubSpot and LinkedIn connected all the time. I have to go back and relink it.
Yeah.
Yep.
So how are we going to do that?
That's the thing, right? And again, in Cloudflare's defense, they're not talking about zero authentication. They just use conventional authentication tokens, and MCP is fully able to do, standard authentication tokens. But like you said, that introduces a sense of fragility and sort of a black box nature to it, where you're just not sure where did it get this token, who's it authorized as, how do I control this? And the blinking 12 o'clock problem. We're all going to face that problem, because it doesn't matter how smart you are when I said black box now twice. Here, I'm going to say it again. When you're faced with, fundamentally, agent to agent is a black box. You're saying, here's some tools that you can use. Now, they do, again, to Cloudflare's defense, they're running these things in a sandbox. They're using authentication tokens. But it's the step of having the agent create its own code that gets me a little scared. Their justification is that LLMs, the trouble with MCP, and this is actually kind of a clever thought, the trouble with MCP is that LLMs were never trained on any data set that contains MCP calls, because MCP didn't exist when they were being trained. And so it doesn't understand fundamentally how to deal with the special MCP tool calling token and how to call tools, even if it's been fine-tuned and to handle MCP. It's not fundamental to its training. Whereas allowing it to redo everything in TypeScript, it has a huge experience with TypeScript, and it's able then to more effectively execute. All that I agree with. It's just, but that doesn't change the fact that we don't know what it's executing. And nobody knows, because it's executing in a sandboxed environment that's ephemeral, and then it evaporates.
It also doesn't change the fact that right now, code generation capabilities are at the infancy, right? Very, very immature stage. And so the probability that it generates code that does something wrong is relatively high today.
Yeah, go generate some code and go execute it, and don't ask me and don't show me.
Exactly.
Now go.
And AI likes to generate a lot of code for you on your behalf, even if you don't want it to. You have to be careful with it. Well, good stuff. We've covered a range of, what about the MCP? What about MCP? It's like the weather. Who's doing something about it? Or agent security. So I have a feeling we're going to talk about this topic a lot more. So stay tuned. We'll be back, and we'll be jump to our next topic.
You've earned it. The spotlight, the responsibility, the weight of teams, companies, and entire industries fall on your shoulders. Lives depend on your decisions, your home life included. At work, you're protected, physically and digitally. Nothing gets through your team without a fight. But in a globally connected world, everyone sees you, including those who mean to cause you and your organization harm. And now home, your sanctuary. Attackers see an opportunity. Your digital front door is wide open. And what compromises your home can breach your boardroom. Because the devil's greatest trick isn't targeting your workplace firewall. It's convincing you that your personal life isn't at risk. Black Cloak. Digital executive protection, defending the new attack surface. Your personal life.
Well, we're talking about Security Day. It's Security Day on the Textron gang. There was a great article on DevOps.com talking about the big secrets leak, if you will, that has to do with VS Code, Visual Studio Code, developer tool, IDE, through extensions leaking secrets. Wiz had earlier this year announced the discovery about how many security supply chain leaks that were due to these extensions, not only in VS Code, but also OpenVSX Marketplace. And then Microsoft researchers found that publishers of more than 100 VS Code extensions leaked access tokens that would have enabled a bad actor to distribute malware to more than 150,000 users. Yeah, that's not bad. It's kind of a small number, isn't it? So it just shows you the attack or the leakage surface of data and security credentials, secrets, is as far wide and as deep as you can make it. And now we're talking about developer tools. We're talking about MCP. That's now also part of the developer tool space. So what are the security folks going to do about this, Jack? When are you going to fix this for us?
When are we going to fix it?
No, when are you going to fix this, Jack?
When am I going to fix it? There you go.
When are you personally going to fix it?
Well, I'll use a very simple analogy that the IDE, the integrated development environment, is effectively the web browser for developers, right? It's their main way of they interact with things. And extensions in the IDE interface are the equivalent of the extensions in a web browser. And so we sort of have it's the exact same problem we've had in web browsers for a while. If you have rogue or malicious or poorly programmed extensions, they can come in and get access to your passwords, see what you're typing, yada, 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 the same sort of security things. And so, we have a couple of, in the security world, we now have a couple of startups doing browser detection and response, which I wrote about recently, like SquareX, who has an extension that goes out and tries to protect the user of a web browser from malicious activity by either websites or other extensions. And now maybe we'll go and see developer environment, IDE security tools that are going to have to be third-party tools to come in and look at this. Or the other option is to go towards more of the Apple model, where you have a walled garden and somebody, Microsoft for Visual Studio, and goes out and vets the extensions to say that this is behaving properly or not. And that's an awful lot of work on both cases. So I don't know.
Yeah, on the SquareX thing, I have to say, we did just have them present at Security Field Day. So if you want to learn what that's all about, you can just Google SquareX and Security Field Day, and you'll find a video, which is a deep dive demo of exactly what they're doing. But absolutely, the thing that gets me about this, kind of in relationship to the previous discussion that we had, the leaking of secrets. I mean, we just talked about tokens and secrets in MCP and how that works. The leaking of secrets is one of the primary things that jailbreakers are trying to do with AI models. Basically, figure out how to make it leak secrets for me. And there are many ways, and you cannot fundamentally prevent that except by having sort of a convoluted calling process. Like, I could see a situation where somebody could have an MCP tool that exists that is only a secrets vault. Maybe 1Password should do that. And basically have the agent call a tool that it doesn't have visibility into, and then that tool then basically just provides the token on your behalf or something like that. Because if if it can see the secret, then it can leak the secret. And that's the problem with this VS Code story, is that essentially people left the token, the secret, in the code. And the thing is, black hats are literally, I mean, they basically just have regular expressions searching for, tokens and secrets on GitHub and VS Code and everything constantly. So if you do it, even for a moment, if you commit that, oh man, oh no, let me get rid of that, well, guess what? You just, it's gone. As soon as you say it, it's gone. It reminds me of the situation back in the day when we would set up, Windows servers, and within literally 30 seconds, somebody was hitting known vulnerabilities in Windows to try to, hack into those servers over the internet. So you had to install, Windows servers disconnected, because otherwise somebody would hack it before you could even apply the patch. It's kind of the same thing here. And in VS Code, what it sounds like too, people didn't even do that. They didn't even get rid of the stuff quickly. They just did it and didn't know that they did it. At the end, you're talking about, you're thinking about vibe coding, you're thinking about AI written code. I think there's a very good chance that AI is going to put some sloppy code out there that's going to include tokens and secrets and that aren't properly managed.
Well, and it's not, rookies doing this too. I mean, they found, extensions that came from OpenAI and Gemini, Google Gemini, Anthropic, Perplexity even, as well as AWS and GitHub, et cetera. So these are, weren't just kind of rogue actors out there who left their secrets in their extension. And there are things to do exactly like you're talking about in the development world. One of the popular open sources, one is called Vault, and that's the way it is. The secrets are stored there, and it's only because of the trust relationship you set up between your code, your system, and that vault that gives you the access token to get that credential, that secret. I kind of faulted at the IDE level. This should be built into the IDE. Right. And you can use secrets managers in VS Code. But that should be part of it. It should be very easy to manage secrets already, just right in the IDE. Pop it right there. It already has, I built the trust relationship when I installed it. This is my test environment. This is how I hook up to my corporate environment. That should be part of how that's set up. I mean, security is set up from the beginning, not after the car leaves the factory and we want to add airbags.
Which is why my column is secure by design. I really fundamentally believe we need to think about security at day one. When we talked about MCP earlier, we didn't think about the identity portion of the security of MCP. When we look at the IDE is something that has grown organically over 40 years, right? When I was an engineer many, many years ago, we used a text editor, right? There was no integrated development environment. You didn't have all the tools integrated. You had a screen to do, you typed your code, you exited the editor, and then you invoked the compiler, and then you invoked your test environment. So in systems that have grown organically, we haven't really thought about security at the beginning. And I think it's clearly time to sort of take a pause and say, how do we sort of rethink this so that we can import the security tools that we need into it, such as secrets managers built into the IDE environment, and not only that, but how do we make it a standard operating procedure of how we teach programmers and engineers to develop, is to think about that and to use the secrets manager rather than hard coding it.
Yeah,
but
maybe the IDE could enforce that and basically refuse to allow you to put secrets in your code to start with.
I think it's something you brought up earlier, Mitch, was that you named the rogues gallery who's who of AI as part of the group that created extensions that leak code. And my question is, and something Stephen brought up, is, was that code that leaked the secrets written by a human or by AI?
Well, that's a good question.
Was it the same code for all of them?
I bet money is by both.
Was it written in 2025? Probably AI.
No, and I didn't name all names. I'm holding some.
No, absolutely. There was a lot more, but
All right. Well, I think so. The parting thought is when we talk about software supply chain security, we're usually thinking about SBOMs and package managers and things, source images and things like that. We have to also think about the tool chain. We're now using AI based browser tools to do development and running agents in browsers, right? So all of that execution environment, either for development or production, all that has to be secured. So it's the tool chain too, the whole part of it. That's how SolarWinds happen. So we'll be back. We're going to finish up on the security theme. One more topic.
Discover TechStrong Group, the epicenter of tech innovation. We're your go-to for reaching IT leaders and practitioners worldwide. Our secret? Impactful content that sparks awareness, engagement, and top-quality leads. With us, you'll access editorial websites, streaming videos, virtual events, custom content, analyst research, and more. Join our satisfied clients. Let's revolutionize your tech journey. Contact us today and tell your story to the world in the most powerful way with TechStrong Group.
Well, welcome back. We're going to shift a little bit and not just pick on AI security. That's a little bit too easy at the moment, I think, in some ways. We're going to talk about really the runtime environment for cloud native applications with AI powered security. Okay, there's an interesting thought. Now, of course, when we talk about cloud native, we're usually talking about Kubernetes, at least as one of the technology that's pretty common to run. And we also look at visibility through things like observability type tools, things like that. I know this is an area that you looked in a little to in preparation for today's segment. Jack, give us kind of your rundown.
Well, I think, in one of the articles that Alan wrote, and I think he said it best, which is you can't secure what you can't see, right? And so we really need to think about in a cloud native Kubernetes environment, how do we understand what's actually happening in the running environment, not necessarily in the development or code environment. So you'll have, and as we talked about with the first segment in MCP, you will have instances of your application either talking to other instances or talking to other resources in your environment. And you probably won't have visibility into all of that because it might be either in a process communication on the same server or going across a local connection that's not part of your outbound network security protocols and what you're looking at for network security. So if you're not observing what's going on, you can't understand if something bad is happening. I think that's the crux of the problem. And so as you start having AI developed code and AI running in your environment now, there's a whole lot more happening that you don't know about. And so trying to get a handle on that and visibility into that, I think is critical.
There's an interesting thing too in Alan's shimmy take at the end of this article. He talks about it's not humans versus machines for security. It's humans and machines working together. And with AI, since agents and AI often mimic or do things that are essentially what a user would do, whether a developer or an end user. So machine identity doesn't kind of cut it anymore in what we traditionally think of a machine-to-machine identity security mechanism, because the actions it's taking is actually looks more like an end user, or is, frankly, it's just a digital user.
It's so interesting how similar this is to our discussion of MCP, in that this whole idea that cloud native applications can and absolutely do spin up and then destroy containers that are basically, I'm going to call them agents.
So a microservice could be an
absolutely
agent.
It could be.
And that they create these agents, that they run something on them, and then they destroy the container afterward. It's the same challenge. And I do like the idea of, kind of turning it over on its head. It's kind of like what I was talking about with NetApp and their MCP kind of protections by doing AI-based data classification. The idea of using AI, not, it's not like running AI applications. It's basically just throwing some AI at the problem by saying, hey, AI, keep an eye on what's going on in this environment all the time. I like the idea because it's just another tool. It's another, quote, set of eyes, even though it's not really a set of eyes, but it's another opportunity to discover something going on in this environment. So, by having AI watch non-AI things, I think that's one of its better uses. I've been pretty excited about AI assisted firewalls. I'm pretty excited about AI data classification. I'm pretty excited about, AI assisted security generally, because not that it's going to solve the problems, but that it has a chance, it has a shot of detecting things that we wouldn't normally detect. Do you see that too?
I definitely do. I think for me, one of the differences here is when we think about, AI is a very broad encompassing term. One of the challenges when you think about an LLM, a large language model, it is designed to be non-deterministic. Give it the same inputs and it gives you a different answer. When we're doing analytics, which is essentially what we're talking about here, is looking at a series of data that's repetitive, the same type of data, and really looking for anomalies, right? That is what traditionally is called machine learning, but is designed to be very deterministic. Give it the same inputs, it will give you the same outputs. The advantage that machine learning has is that it can operate at a speed and scale that humans can't. So it can look at a vast amount of data that humans can't deal with in our heads, and can do it very, very quickly. And that allows you to look for anomalies, bad behavior, or strange behavior over a greater period of time. So one of the things that attackers try to do is they try to operate low and slow, like cooking, right? Where
ACP attacks, right?
I'm sorry?
ACP type
Yeah,
attack.
ACP attacks, where basically you're trying to exfiltrate data, but if you send a couple of packets every second rather than a couple of gigabytes every second, you might escape notice. And so they can operate over very long periods of time, 30, 60, 90 days before they're discovered. And during that time, they're able to exfiltrate a lot of data. It would be very hard for a human looking at the data, the telemetry that you have about what's going on in your network, and find something like that, because it's literally the proverbial needle in the haystack. But it is something that machine learning program can do. And I think it's a very good application of AI to look at these vast amounts of telemetry about what's going on in our environment to identify things that shouldn't be happening.
Well, I like the promise of where we're going, because we've gone from, let's do log aggregation, get a whole lot of logs in one place so we can find them. Let's put them all into one system so we can do analysis and application performance monitoring. Let's put more sophistication to it and have observability so we could do more analytics on it and connect the dots across the organization applications. So the next layer, in addition to AI being part of the solution, is graph technology, which is adding context to that. HashiCorp announced they're claiming the moniker of the agentic infrastructure, adding AI capabilities into what we do with Terraform. But what it's informed by is something called infograph, which is their graph technology that is the state of what the infrastructure looks like. We were talking earlier about code generating code. Well, and you use the infrastructure code example, and that's a perfect one. If you're doing it in isolation, go create this. That's one thing. If you're doing that in the context of a larger system, well, how do I find out what that is? How does AI find out what that is? That gives you a lot more, I think, validity to be able to handle not only the volume, but the breadth you were talking about, Jack. I think there's a lot of promise in that, in helping solve some of these issues.
Well, I'm glad you brought up sort of the graph concepts, because that's something that Microsoft itself is also thinking about. Microsoft participated in a Tech Field Day exclusive event, and they talked about how they're integrating graph and the concept of graphs in the graph database into their SIM and their entire AI security platform. And part of it is that attackers think in graphs, right? They think about, I've penetrated this particular server or host or device endpoint or user. Now from there, what's the graph look like that I get to the next part and the next part to explore, because they don't have visibility into the entire infrastructure at once. So they sort of have to build that out, and they think about it in terms of graphs. So if you can build your tools around the same way that the attacker thinks and understand the graphs of how your systems are interacting with each other, it gives you a leg up in understanding what's going on and trying to be one step ahead of the attackers.
Stephen, how much is graph technology coming up in the vendor events that you're doing with field days?
Yeah, we're hearing about it a lot more. And this whole idea is absolutely coming up from sort of people who are companies that are ahead of the trends, instead of sort of looking at things the old way. I don't know enough about it yet, but I do know that we have seen it and heard about it from a wide variety of companies at Field Day, and I'd be really interested to see where it goes.
Oh, we will have to get Neo4j or somebody like that into a field day.
Yeah.
And love to have somebody, or anybody else, by the way, if you're interested, contact Stephen or anybody here. We'll set you up. And I think that'd be a fascinating set of conversations. So, well, good. Well, gentlemen, it's been fun. I feel like we're missing the Allen drummer, and but we decided to do the Rush band and just kind of fill in. So we've got the trio back together, just with some new players. So good to have you here, guys. Have a good week, everybody. Thanks for watching today. Be sure and check out. We talked a lot about Tech Field Day. Thankfully, Stephen was here. We could touch on that. Well, Jack too, because you've done a number.
Do a couple of those.
And be able to check out techfieldday.com.
Yeah, actually, if I may, so we're just posting the NetApp videos that I mentioned in the first segment, but also this week, Wednesday and Thursday is Cloud Field Day, and that's going to be streaming at techstrong.tv.
Fantastic. So stay tuned. So starting tomorrow, right? Wednesday, what'd you said? Wednesday, Thursday?
It's Wednesday and Thursday, 22nd and 23rd.
Very nice. Very nice. Excellent. Well, everyone, be ready, because we're going to be talking about agents and MCPs and runtime security a lot, I'm sure. All right. Well, be safe out there, and please check out the rest of the programming that we've got here on the TechStrong TV, the great shows and interviews and conversations that are happening, things like Tech Field Day as well. We will talk to you soon.